This is the mission 60, organized by Space Analog Station Habitat Marte. And today we have the presentation of Deepanshu Mathur about the Engineering Center. Okay, good luck, Deepanshu. You can start.
Thank you, Professor. So, throughout the history, humankind has shared an innate trait, the desire to explore. Prehistoric man may have stood curiously at opening to the caves and wondered what was the above the next hill. Centuries later, on 20th July 1969, first man marked his footprint on the moon, and now we are aiming to Mars. But how? What technologies, what science do we have to make a sustainable habitability on the red planet? Hello and welcome. I am Deepanshu Mathur, Engineering Center Chief for the 60th Analog Mars mission at Habitat Marte. So, this is the agenda for today's meeting. I will be covering design, technology, management, protocol, as well as spin-off. So, coming to first, that is design. I have bifurcated the design into two parts. That is, one is internal design and another is external design. So first, here is a 3D proposed layout of the Habitat Marte. So coming to the external design, Habitat would be directly exposed to the harsh Martian environment and therefore must possess very good mechanical properties. External structure will be a 3D printed thick shell structure made with the Martian regolith. The structure works great in compression, but not in tension. So it will protect astronauts from harsh radiation of the sun because Martian regolith is very good in shielding against the radiation. It will also shield from dust, storm, and any other catastrophes like debris from the space and micrometeoroids. But as we can see that this shell structure is good under compression. So we can use this to shield against any kind of meteors or radiation shielding. But we cannot directly create a pressure difference like 1 bar pressure difference, like 1 bar inside and 0.006 bar, which is the atmospheric pressure of the Mars, because it will then damage our shell structure. So what is the solution? The solution is to make an inflatable dome. Yes, the lightweight inflatable dome to retain the pressure near the atmospheric pressure of the Earth. Its cost of transportation will be very less compared to the metallic structure because it is of course made of some kind of fabric or some layers of fabric. So the material used should possess high impact tolerance, tensile strength, puncture resistance, creep life, temperature resistance, and radiation resistance, and flex resistance. So this would require high space grade materials that satisfy all these requirements in addition to being lightweight and cost effective, of course. So as we all know that the atmospheric pressure on the Mars is 0.6 kilopascal, which is even less than the 1% of that of Earth, which is around 101 kilopascal here on Earth. So we have to maintain a 70 to 80 kilopascal pressure inside the habitat. And of course, temperature plays an important role because the Martian average temperature is minus 63 degrees centigrade. And we have to maintain around 20 to 30 degrees centigrade temperature inside that habitat, as we all know that in the average temperature inside the International Space Station is also around 24 degrees. Now coming to the material, or we can say what will be the layers or what materials we can use to design our inflatable dome. So habitat will be made in the multi layers to fulfill the various shielding requirements, which are radiation shielding, temperature shielding, structural resistant, gas restraint, and fireproofing, of course. So material used here will be the Kevlar, Vectran, Dacron, Xylon, Technora, and Spectra. These are some of the space grade materials which can be used to fulfill all our properties. So we need these kind of properties which can be attained in some kind of combination of these material like impact tolerance, tensile strength, and various others. Now, coming to the internal design of our facility. The facility will be designed in such a way to fulfill all the requirements as well as provide comfortable living environment to the astronauts. Facility will be divided into the 3 floors, each floor serving some different functions, including control center, research lab, workshops, dormitory, training room, dining room, etc. And of course, a vertical garden for plants that we will be using for our meal. So now coming to the ground floor. So the ground floor will be having first is the control center, a laboratory, research and development area, maintenance and parking facility, and unloading and storage area. So now, as we can see here, that I have made some kind of extension in the maintenance facility maintenance area. This maintenance area or the extended area will be used for parking as well as maintenance, and of course for the battery charging of various our drones, as well as various other vehicles which we are using for EVAs, extravehicular activities. And also this will protect from any kind of dust storm. And also as we can see there, that here I have mentioned uh, unloading site very near to the maintenance of the parking facility. The reason being that unloading site will be directly connected to this area to easy and safely unload and store all the excavated materials, may it be the regolith, ice, or any kind of mineral. Now, coming to the first floor we will be having a training area, recreational area, library, dining area, and a vertical garden for the food. Now, going to the second floor, we will be having sleeping area, that is dormitory, meditation area, or some kind of exercise area, we can say, we can put over there as well, and an internal garden, a small internal garden with some greeneries, and of course an exercise area for the astronaut. Now, as we can see that I have placed the vertical a small garden very near to the meditation zone, because the reason being that this garden will provide a pure and fresh air to the astronauts, and also greenery is good for meditation also. And one more thing, why do we need to do exercise? We have seen in the International Space Station that astronauts have they have a specific dedicated time to do the exercise, and it is their routine. Because the reason being that we here on Earth are living in 1G, and when we go to the Mars, there we will having around one third of that of gravity of Earth. So we will start losing our muscle mass as well as bone mass. So we need to do the regular exercise for safety of our only and for our health. Now, coming to the second part, that is technology. So here what I have proposed is that we will be using an integrated environment control system. Yes, the integrated environment control system. What is that? Integrated environment control system is something like a computer system. It will work autonomous habitat management system. It will control and deliver essential services like power, data, water, oxygen, and communication. Now, the ECS will work on artificial intelligence and machine learning, and integrate Internet of Things, that is IoT, to connect all the facilities, machines, services like power, air, water, etc., using the internet. So, where we will going to integrate this thing? So, as I propose is that installing of these this ECS in the connector module. What is the connector module? Is that this lawn which we can see, these all these lawns which we can see here and here, all these are connecting the other each and every facility to other facility. So we can put the these ECS in this connector module. Well, the benefits of installing the connector module is that it will not use any kind of space in the facility, because as we all know, we have some kind of very limited facility. So we have very limited space for every facility, and we can install this ECS in these connector module only. So, and moreover, connector module can be used to cut the supply of any specific facility on the center in case of emergency of catastrophe. Now, ECS will work as safety system, as it will continuously monitor all the data of complete station, and it will, and if any abnormality is observed, like sudden pressure reduction in any specific center, like because there might be some kind of puncture in the our inflatable dome, or there could be the leak of air or oxygen, then it will provide warning signal to the main station, but also it will continuously increase the supply of air so that there would be the comfort for the astronaut. And ECS will work on artificial intelligence and machine learning. Yes, this is the thing which is being used in nowadays in every kind of machine to integrate artificial intelligence and machine learning. So this will work autonomously by taking some decisions for the safety and the comfort of the habitats, by also taking care of the control to by taking care to control over the power consumption. Also, it will improve the design and it design itself according to the needs of the station using machine learning. Like if we say that we have designed this software or this system according to some specific parameters, but it eventually it will start learning that what kind of new problems or new warnings could occur, like what new catastrophe can happen. So it will start learning itself by observing these things, and then it will improve its programming eventually. It will work as early warning and control system, that is EVACs, by continuously analyzing all the systems of the station and indicating to the engineering center and the main station simultaneously about any hazard that may happen in future due to some minor issues which is not visible in the routine working. As we all know that we are humans and we have some kind of limitations also. A single human cannot continuously monitor each and every machine inside a facility, no matter how much trained he is. But a software or a computer can. Computer can monitor continuously each and every data to check if there is any kind of error or mishappening in uh, the normal habitat working. So now, if there is any, let us suppose if there is some kind of fire breakout in certain facility. So what it will do is that it will automatically cut down the electric supply and stop the ventilation to cease the fire, and will ensure the proper and safe passage to all the astronauts out of the facility. In the meantime, it will also send the warning signal to the main station. So these are some kind of example. These are some examples of facilities. These are some kind of examples of usage of this ECS. Now, let us suppose if there is some kind of emergency or mishappening happened in the any specific station, and this system is unable to determine that, but astronaut has identified that problem. So what astronaut is going to do? The astronaut, as soon as any issue is reported by the astronaut using ECS, it will directly send the message to the main station, and parallelly it will try to identify the threat and eliminate it. Now, this mechanism has been adopted using the reflex action of the human body. So what the reflex action is? In the higher animals, mostly sensory neurons do not pass directly into the brain, but synapse in spinal cord. This allows reflex action to occur relatively quickly by activating spinal motor neurons without delaying of uh, relaying signal through the brain. Although brain will receive the sensory input while reflex action works. So as we all know that if we touch any kind of hot object, so before the signal reach to our brain, we have already removed our hand. Why this happened? Because of the motor neuron in the spinal cord. So this is something like which I am going to integrate, or I am proposing to integrate inside the ECS, that we will be doing this thing only, that when we report some kind of signal, it will go to the brain, and similarly it will go to the main station, and in the meantime ECS will try to eliminate that threat on its own level. So this is some kind of we can as we can see the dashboard which will be visible to the engineering center and the main station, using all the perimeter showing all the parameters visible to various facilities. Like we can see here, temperature, humidity, any kind of pollution, pollutants, carbon dioxide, light, other things, as well as air quality. There are many other things which will be visible through this dashboard to the main station. So the main and also main station will be able to control all these parameters according to the need. Now, coming to the second technology, that is 3D printing. 3D printed tools, parts, and machine components can be used on the station. This and also the maintenance equipment, R&D projects, and prototyping. It will reduce the cost of carrying everything from Earth, and also decrease the dependency of long waiting time between the subsequent missions from Earth to Mars. As we all know that it takes around 26 months from to Earth and Mars to come closer, and this is a very big time if we consider that there is some need of some equipments or some machines, and we are waiting for 26 months. This is not something kind of feasible activity if we are planning for a sustainable habitat on the Mars. Here are some of the 3D printing technologies which I have mentioned here. So this is 3D printing of our own 3D shell, which I had mentioned earlier in the external design. And here we can see this is the wrench, which has a two wrench tool, which was 3D printed on the International Space Station. Now, coming to internet and intranet. So here I have defined two different kind of network structures. Internet will be mainly used for the communication with Earth-based station and all communications outside the habitat. Internet will provide secure and fast network for communication and data transfer inside the habitat. Using intranet separately will reduce the load as well as latency in the data and information transfer. And also, of course, there is much threat of any kind of hacking, or there is intervention of any other person inside, but this intranet can protect from that. So now technology is necessary for external operation. So the external or EVA activities include mining, excavation, regolith collection, soil sampling, water ice collection, etc. For all the EVAs, we need special purpose vehicles and machines like Land Rovers, land movers, excavators, Mars buggy, drones, helicopters, swarm robots, etc. So here we can see these are the swarm robots, and we can use them as multi-purpose vehicles. Here we are using it for the excavating of the Martian regolith. So next is helicopters and drones. Helicopters on Mars are faster and capable of covering more ground than the rover. It can provide higher resolution image as compared to orbiter, and it is very difficult, but it is also very difficult to fly the drone or the aerial vehicle in the thin atmosphere of the Mars, because but yes, helicopter can be designed lightweight enough and blade rotate faster enough for the flight to be possible. Here is a image of the Ingenuity helicopter, which has been integrated in the Perseverance rover, recently launched by NASA. As we can see here, the specification of this Ingenuity rover is that it weighs less than 4 pounds, and the fuselage is about the size of a softball. And also, counter twin blades will rotate at the speed of 3000 rpm, which is something like almost 10 times of that of helicopters we use here on Earth. Now, another is modular swarm robots. Modular swarm robots can be used for various purposes like transportation, surveying, and sampling. And robots can be used to perform ultrasonic scanning or to analyze the Martian surface for the best regolith. Now, like this is the image which is showing the ultrasonic scanning of the swarm robot. And as I had earlier mentioned, that it can be used for multi-purpose vehicles. Like here is example of an excavator. Here we can use this for lifting some heavy equipments, etc. So now rovers and ground vehicles. This will be the most used system for transportation for regolith, minerals, and ice water, and astronauts and EVAs. Vehicles will be powered by batteries and also solar power. Integration of solar panels on the battery powered vehicle will reduce dependency on the batteries and hence on the main station. While on longer distance research trips on Mars, solar power can be used to commute, and batteries for the EVs. Now let us suppose if we only integrate batteries, then what will happen is that there will be the limitation for our duration of the trip, because batteries will have the limitation of their capacity to charge. But we can use solar power for this thing, so that solar power will be used for any kind of movement of the vehicles, and batteries can be used for any EVs like excavation or research activity. So solar power vehicles design, what I have proposed is that the solar power design is inspired by the solar car. Here we can see solar car, which is Tokai Challenger. This is a Japanese car design, which is of course very lightweight, because there are no any kind of engine introduced in this, and there will be only motors, and motor has to do very less work, so it will move really fast. And vehicle tend to be flat and wide to maximize the surface area while still being aerodynamic. As here we can see, these are the solar arrays which are being used. So many solar power cars have the maximum speed of between 40 to 60 miles per hour, and the maximum array output of the solar panels is around 900 watt, and maximum speed is 120 kilometers per hour. But there is a difference. These all datas are applicable for Earth only. Now, there is a difference between these datas on Earth and on Mars. Why? Because of the reason being that there is solar irradiance difference. The energy which Earth receives is 1380 watt, that is 1380 watt per meter square, and that on Mars is 595, which is almost less than half of the total energy which Earth receives. So what will happen is that we will receive obviously lesser output on the Mars from these solar arrays. So the solution could be we need larger solar arrays to grab that same output of the power. And also, but as we all know that we have very limited parking space. So for that, larger solar arrays would become some kind of trouble. And also one more thing is that there are Mars storms. What Mars storm does is that they deposit all the sand all over the solar arrays. As we can see, here is an here's the image of the Opportunity rover. This is the image of earlier and after the solar storm. So we can see that the storm has covered each and every part of the solar panel. As we all know, the how the Opportunity rover got its to its reach to its end, because that was you can blame the Martian storm for that, because Martian storm completely covered its all the solar panels, and eventually its battery got dead. We don't need this thing to happen, at least to our vehicles, if we are planning for any sustainable presence on the Mars. So what could be the solution? The possible solution could be found in the ancient Japanese art of paper folding, that is origami. Yes, the origami. Now, this might look some kind of science fiction, but yes, this technology can be used on for our technology. This is some kind of amalgamation of technology and the art. The solar array can be folded while in the storm or in the parking area to protect any Mars sand from depositing over it and to reduce the space requirements for parking. After unfolding, the area of the solar array will increase more than 10 to 100 times. So as we can see here, an example of this is uh, uh, origami fold design. So when we unfold this, it will become something like this of the size. Here is some another examples. As we can see, when we fold it, it will become of this size, which is very, very less as compared to when it will become unfolded. So this is so now, so we can use these kind of technologies or these kind of help from the art for our science project, science mission. And another folding design could be the Menura fold. Menura fold is like what we can say is very famous in the famous for folding the solar arrays in the recent missions. When we design a satellite which have very large solar arrays, so we use generally this kind of uh, technology or this kind of folding method. Now, origami also increase the strength of the structure, because we all know when we scratch on the surface of the structure, it will create the splines over it, and this will eventually increase the strength of the structure. And also, folding will allow the solar arrays to be transported easily in the rockets from the Earth to Mars, because it will increase the packing efficiency, of course, of the rocket. One more thing which we can use to counter the very less irradiance which we receive on the Mars is that use of gallium arsenide instead of silicon cell, because the conversion efficiency of gallium arsenide is around 37% as compared to the silicon cell, which is 21%. Now, coming to the third part, which is management aspect of the engineering center. So this is the organizational structure of the engineering center. We will be having engineering center chief, researchers, technicians, and assistants. So, engineering center chief will be a multidisciplinary person having management or industrial engineering background, high capacity of leadership, and resilience. So, what will be the duties? The duties will include inspection and control of daily activities of the station, propose routines and operational protocols, and also upgrading protocols, coordinating with all the other facilities for proper functioning, designing of standard operating procedure for smooth functioning of the station, and preparing daily reports to be submitted to the Mars station, to the main station. Second is researchers. Researchers will be some people who are having some kind of science or engineering background. They will be experienced in research and development activities and having problem solving aptitudes. Their duties will include work on research and development activities, responsible for developing new technologies as uh, developing new technologies according to the conditions on the Mars. and upgrading and improvement of existing technologies. Technician will be some person who will be also having technology background and experience in maintenance activities, expert in electrical and maintenance system, mechanical systems. Duties will include doing regular maintenance in all the facilities, performing preventive maintenance, and the assistant will be somebody who is also from the engineering and technology background. He will be expert in the IT systems, and duties will include that he will work as the support staff. He will responsible for the operations at night and will work in the shift changes, because obviously we our astronaut will need the break. So at that time, assistants would be doing their work in their place. So, what will be the responsibilities of engineering center? So, the first and major responsibility will be the maintenance activity to perform preventive maintenance of vital and essential systems to prevent any failure or uh, malfunctioning in future. So, what does preventive maintenance is? The preventive maintenance means to avoid any consequence of component or system failure, to remove anything which could become trouble in the future. This is what preventive maintenance is. Maintenance of habitat and facilities will also include under the duties of the engineering center, and maintenance of vehicle, drones, and robots, as well as power equipment, and also providing the support to the power station, and maintenance of the lab equipments and machines. Now, second will be the upgrading of existing system, expansion of habitat for the future, and accumulation of more astronauts. As we all know, if we are planning for a sustainable presence on the Mars, we will need more and more astronauts for to do more science, and of course for the habitation there. So we need a larger habitat for that, and for this we need to expand and that will be the responsibility of the engineering center, increasing the safety of the station by developing advanced protection system and upgrading of power generation system with support of power facility, developing of tracks and roads to the launch sites, energy farms, kilo power, solar arrays, and areas with maximum movement of the vehicles like ice crater, etc., from the station to provide easy movement of the vehicles. Third is the routine inspection of the space suits, vehicles, drones, testing of equipment in all facilities, checkup of gadgets like smartwatch and health monitoring devices, and ECS, that is Integrated Environment Control System, for proper working. Fourth is training of the astronauts for safe handling of machines to deal with any catastrophe or emergency, new skill based on situations identifying at Mars, managing mental health, and practice to reduce cost and technical risk in overall system. Fifth is the research and development activities to develop new technologies according to the Martian conditions, supporting R&D activities in various stations, developing new technologies for radiation shielding during EVAs, because we know that we can shield the astronauts from the radiation inside the habitat, but astronauts are not designed astronauts have not been sent there to stay inside only the habitat, but also to do some kind of science and extracurricular activities. So we need some new technologies to improve the radiation shielding capacity of our astronauts, and developing of swarm robots and drones to search for new excavation sites for water and minerals. Next is ensuring proper communication systems and internet facility in the habitat. Continuously monitoring of integrated environment control system, weather monitoring systems, and reporting to the main station to plan extravehicular activities, and reporting to the main station about everyday activities. Now, coming to the fourth aspect that of the management, that is resource management. So we know that resource management is one of the key element for proper functioning of the any station, because resources on the Mars will be very limited and has to be recycled and reused multiple times. So management of food and water is especially necessary since mission challenge is to stay in the isolation for at least a week because of the virus threat. It is necessary to grow food in the vertical gardens inside the facility and also to have a stock of space food, because we all know that the vertical gardens will also having some kind of limitation. They cannot continuously serve every time to all the needs of the astronaut. So we also need some kind of space food, which of course astronaut eat in the International Space Station. So astronaut generally eat 3 meals a day, that is breakfast, lunch, and dinner. So nutritionists ensure the food astronaut eat provides them with a balanced supply of vitamins and minerals. Calorie requirement differs for an astronaut. For an instant, a small woman would require 1900 calories a day, as compared to a larger man would require 3200 calories per day. So astronaut can choose from many type of foods such as fruits, peanuts, nuts, butter, chicken, beef, seafood, candy, brownies, etc. There are also multiple drinks available like coffee, tea, orange juice, fruit, and lemonade, of course. Now, if we can let us consider that there are 3 to 5 astronauts inside the facility, so the food requirement per day would be 2.1 kg per person, and weekly would be 14.7 kgs per person, and for the total for a whole week for the for a facility would be 44.1 kgs to 73 and a half kgs would be the food requirement. Now this is something very interesting. This is the standard menu of the food on the International Space Station. These are the various food provided by the for the astronauts on the International Space Station. So we can also carry these food as our stock for a week. Now, coming to the management of water. So the consumption of water for the various uses are mentioned over here, like drinking, water for food, and shower, as well as toilet and brushing. So the total consumption per person per day will be around 7.37 liters, and consumption per week for all the 3 to 5 astronauts would be 154 liters to 257 liters. Now, this is something very conservative data because I have not included many other things, but these are some of the essential requirement for any astronaut to stay or to live on any habitat. Now, coming to the fourth aspect, that is protocols. Protocols for the engineering center. So, protocols will include first protocols for routine of the facility. The routine will include maintaining proper hygiene standards, cleaning of facility and all equipments and machines to protect them from the Martian sand. Because we know that the Martian sand is extremely fine and it could enter inside our equipments and harm them, as well as they are also the Martian sand is also harmful for human health. Maintenance of the station, maintenance of vehicle, drones, and bots, and also everyday reporting of each and every activity to the main station. Second is protocol for safety. So the regular sanitization of the station is very essential, especially if there is some kind of virus outbreak or there is a threat of virus. So we need to regularly sanitize the complete station, and there should be the protocols for proper handling and sterilization of the space suits after extravehicular activities. Like how we will be going to put our space suits, there should be some kind of protocols for that. Training for safe use of equipment and deal with emergencies and accidents. Third is protocol for occupancy and entertainment. Schedule time for recreational activities, games, celebration. As we know that there is also a specific scheduled time on the International Space Station for all the recreational activities, games, and celebrations. Like they celebrate New Year's as well as other various national and international days, Christmas, and etc. Library and reading suggestions, and get together of whole crew every day to bring a harmony among them. Now, protocols for well-being and health. There should be the protocols for maintenance, yoga, gym, and exercise. Fifth is protocols for 3D printing. So, manufacturing most of the things using Martian soil and minerals available on Mars. This would be very convenient as well as effective for a mission for sustainable presence, so that we can cut down the cost of the transportation from the earth, recycling of dead rover parts as well as materials to produce the new ones. Let us suppose we are having some kind of rovers which are now dead. So instead of just throwing them, we can use their parts which are still working, and also recycle all the other dead parts which are no more used. So we can just recycle them for the reuse, and 3D printed machine tools and maintenance equipment. Now the spin-off, these are the things which like technologies and outputs which we will be using, which could be applied on Earth. So the swarmed robots and swarm drones for the surveillance and the research activities can be used on Earth, as well as water recycling system. As we all know, that today most of the countries are facing this water trouble, especially in the summer time. So we can use water recycling system, so that and also plan the effective usage of the water. Like there is a limited water available on the International Space Station, as well as if we are planning any habitat, so there will be the limited use. So we will be planning each and every we will be planning how to use these the water on the space station. So here also on Earth we can plan these things to fight that shortage of the water, for the shortage of the drinking water on Earth. And also 3D printing of for low cost additive manufacturing, 3D printing of the body parts. As we can see here, this is a human ear which has been 3D printed inside the lab. And also this is the jaw which has been made using titanium. So jaw can be 3D printed using titanium if there is some kind of accident happen and the jaw break. So the bone replacement can be done using the 3D printing technologies. And of course, solar powered vehicles can be used on Earth. So guidelines to be applied to daily life on Earth are mental well-being, daily routine and guidelines, health occupancy, health and environment, and safety guidelines. So now coming to the last point is that impact to the sustainable development goal, which is good health and well-being, gender equality, affordable and clean energy, industry innovation and infrastructure, sustainable cities and communities, climate action, peace, justice and strong institution, and partnership for the goal. So how these things are included, let me put some light over it. Like we can see that gender equality will be a primary role in these kind of missions. As we can see, even now NASA has announced the team of astronauts who will be heading towards the moon, and they are planning to send first men and first women and the next man to the moon. So gender equality is very important in these kind of missions also. And of course, we will be using solar panels for our energy consumption. So clean energy is important thing. And obviously innovations will be included for these kind of missions. And there will be the collaboration of multiple associations. Like we can see nowadays even that NASA and European Space Agencies and other space agencies are collaborating to create to create a harmony in the space, as well as to promote the technologies in the space. So here are the references of my presentation. So thank you very much. And these are some of the links which like LinkedIn as well as email ID. Thank you.